Okay, we are continuing the notes from Thursday, and we're going to do two more examples where we are solving a quadratic equation using factoring. Just a quick reminder, make sure that it's in standard form. This one is not in standard form yet, so we want to make sure that we get it in standard form before we do anything else. So all we need to do to accomplish that here, we need to divide both sides by 4. So I'm sorry, gosh, that was silly. We need to subtract 4 from both sides so that we have x squared minus 5x minus 14. So that's what we're factoring. So my a is 1, which means j shortcut. I'm going to be able to pick my values and throw them right into that. My b is -5, my c is -14. Remember, I'm going to look for factors of AC that add to b. So AC is 1 times -14, b is -5. So I want to multiply to -14 and add to -5. So 1 and 14, no, that's not going to work. 2 and 7. That's going to work with a -7, +2. 2 times -7 is -14. 2 plus -7 is -5. So x plus 2, x minus 7. So remember, the whole purpose of that, the whole reason we did that, is so that we can take this trinomial, write it as a product, so that we can use our zero product property. So I'm factoring it so that I can use my zero product property, which is what I'm going to do now. So now I have two things multiplied together to give me 0. My zero product property tells me one of those things has to be 0. It's the only way to multiply by 0 is that one of your factors is 0. So subtracting 2 and adding 7. And just like the others, I'm getting two answers here, -2 and 7. Remember, what that means is if I go back into that original equation and plug in -2, I'm going to get a true statement. And if I go back into that original equation and plug in 7, I'm going to get a true statement. And if I go back into that original equation and plug in anything else, I'm going to get a false statement. Okay, let's look at example 4. Pause here if you need to finish, because I know I did that a little bit fast. Here is example 4. So the good news is I'm already in standard form. The bad news is my leading coefficient is not 1. So I'm going to have to do that whole box thing. So A is 2, B is -15, C is 18. I'm going to do A times C, so 2 times 18 is 36. And then B is -15. So I want to multiply to 36 and add to -15. The numbers are screaming at me, but just in case they're not screaming at you, start with 1. That's not going to work. 2 times 18. That is not going to work. 3 and 12. That's going to be the one. I know it's going to be 3 and 12 because if I make them both negative, they will multiply to a +36 and they will add to a -15. Now again, I can't shortcut this one because my leading coefficient is not 1. So first term here, constant term here, and then we're rewriting that -15 as -3x, -12x, and then I'm going to do the GCF. So 2x here, 3 goes into 18, so 3, and it's going to be negative. Here just x, and here 6, and it's going to be negative. If you're worried that you didn't pull out the correct GCF, go in and do multiplication, Be like, does my 2x times -6 equal -12x? Yeah, okay. -3 times -6 equal 18. Yeah, okay. So if you're like, oh, did I get the GCF? Did I get the greatest common factor? If you're not sure, remultiply and make sure it works. And it does. So this is going to factor to 2x minus 3. That's a parentheses there. To x times x minus 6. And again, the whole purpose here, the whole reason I did this is to get that factored form so that I can go, ooh, I've got two things multiplied together to give me 0. So one or the other has to be 0. I'm going to set each factor equal to 0 and solve. So on this first one, I'm going to add 3. And divide by 2. And I'm going to leave it as a fraction. And on this one, I'm going to add 6. So once again, I get 2 answers, 3 halves, and 6. No parentheses. A parentheses makes it a point. This isn't x comma y. This is x comma x. They're both x's. They both make that original statement true. And that is it for this video.